Come on in and have some fun.
Come on.
So just come in and learn with us with the mouse in the house.
Woohoo!
With Carrie, Inertia,
Yeah.
and Dino and Mariangela. So come on, young scientists, come join the mouse in the house.
Uh-huh. Hi guys, my name is Max. Welcome to my lab. Today, we're making no ordinary bubbles, but super suspended soap bubbles. You will need a soap bubble solution, dry ice, and a large transparent container with an open top. Did you know carbon dioxide gas is called dry ice? Let's begin the experiment. Place some blocks of dry ice in the bottom of the container. Caution, use gloves when handling dry ice. Blow some bubbles so they flow down into the container. Watch closely as the bubbles descend and are magically suspended in mid-air. Because they're very light, soap bubbles will float on the carbon dioxide produced by the dry ice, like helium balloons floating in the air. After a few minutes, the bubbles will begin to expand and sink. Wow! Look at those pretty colors in the bubbles. Okay, kids, let's get bubbling. Remember not to blow directly into the container, kids, because you'll blow the carbon dioxide out. Put a few drops of dry ice into the container. Now gently blow some soap bubbles over the opening of the large container so that they settle into the container. Look at that! The bubbles are floating and not sinking as they usually do. Amazing!
What makes the bubbles float?
The bubble expands because carbon dioxide replaces the air in the bubble, causing the bubble to remain suspended.
Why are there different colors in the bubbles?
The colors of the soap bubbles come from the reflection of white light that falls on the bubble. Cool! Look at that! The young scientists are making such big bubbles. If you want to make your own, this is what you'll need to do. Take an old steel hanger and bend it into shape. Then wrap wool around it. Then you're ready to go. Give it a bash and see how big your bubbles will be. Hey guys, let me show you an even bigger bubble. Come with me in my hot air balloon and be like a bubble and go up, up and away. Now this is what you call a bird's eye view. It's so beautiful up here. An open flame under the balloon creates the hot air inside it, which causes the balloon to rise. A hot air balloon travels as fast as the wind blows. See you back at my lab. Today's green tip is: talk to your classmates and teachers at school about putting recycling bins for paper and plastic in every classroom. Find out about more groovy science projects next time. Bye for now. Spinning around like a top can make you dizzy. Today, we're going to spin a cup of water around and around while learning about inertia. You will need water and a bucket or a mug. Now let's get swinging. Pour some water into the bucket. Now get ready, steady, and swing the bucket around with an outstretched arm. Wow, look at that! No spills! Now you try. Pour the water into the bucket. Now get ready, steady, and swing! Remember to stretch your arm out and also to use a rapid, steady movement. You're really good! Look, no spills!
How does that work?
A centrifugal force, which is to the side, keeps the water in the bucket. This is also known as inertia.
Why can't I bend my arm?
If you bend your arm, the motion of the path will change and the water will spill.
How full does the cup have to be?
You can pour as much water as you want and see what happens. But just know that the more water you pour in, the more difficult it's going to be. So seeing that we're focusing on inertia, I have the best example for you. Now let's get into my space pod and I'll tell you more about it. An amusement park is a place where everyone has a lot of fun. Since our focus is inertia, there are a number of rides that use this principle. Look at that! Look at that ride go! It's going so fast that the pressure that surrounds them pushes the people back so much that it becomes very difficult for them to move. This is known as an inertia force. The Ferris wheel is my favorite ride. It goes round and round and shows you an amazing view. Here's a fun fact. The Ferris wheel was invented in 1893 for the Chicago World Fair by George W. Ferris. Now everyone can enjoy a ride on the Ferris wheel all around the world. That was a lot of fun. Let's meet back at my lab, kids. Let's go green with today's green tip. Use reusable and recyclable shopping bags whenever you go grocery shopping. Wow, that was so exciting! Shoo! I'm so happy to have my feet firmly back on the ground. So today, we learnt about an amazing principle called inertia and saw it in action. Well, that was another great experiment. See you later! In today's experiment, we're going to see the effects between high and low air pressure. We're going to see how an egg magically gets pushed into a bottle. You will need a wide-mouthed glass milk bottle, some cleaned hard-boiled eggs, matches, and a few strips of paper. Let's begin the experiment. Light the match and set the strip of paper on fire. Quickly put the burning strip into the bottle. Immediately cover the mouth of the bottle with the egg. In a second or two, the egg gets pushed into the bottle. That's incredible! Now it's your turn. Remember to ask an adult to help you when lighting matches. Light the stick of matches, quickly put it into the bottle, and immediately cover the mouth of the bottle with the egg. In just a flash, the egg is pushed into the bottle. Wow! That's exciting. Get it? Exciting?
What does the burning paper do?
As the flame uses the oxygen inside the bottle, the air pressure in the bottle will decrease, causing a vacuum. The low pressure in the jar is different to the air pressure outside the bottle. The high air pressure on the outside will push the egg through the small opening and into the bottle. You may think it is sucked in. This is not true. It is pushed.
Can you use a plastic bottle?
Yes, you can. You just have to make sure that the opening of the bottle is big enough for the egg to sit firmly on top. Did you know that besides chickens, reptiles also hatch from eggs? Let's get into my space pod and visit some of these prehistoric creatures. All reptiles are cold-blooded, which is why they warm themselves in the sun. And their bodies are covered in dry, horny scales. The major groups are alligators, crocodiles, turtles, lizards, and snakes. There are over 3,000 kinds of snakes in the world. They have a long, flexible body that is covered with dry scales. When snakes move around, they usually slide on their bellies. Snakes repeatedly flicker out their narrow, forked tongue, using it as a sensory organ. Okay, kids, let's slither back to my lab. Let's see what our green tip is for today. Avoid opening the oven door because by doing that, you lose a lot of heat and therefore waste electricity. Today, we've learnt about what happens when you have 2 different air pressures and also about reptiles and snakes. That's what science is all about. Cheers till next time. Today, we're going to see the world's coolest dry ice crystal ball. You will need dishwashing soap, a piece of cloth and a bowl, a large bucket filled with water, a few pieces of dry ice, and gloves. Let's begin the experiment. Pour the dishwashing soap into the bowl and soak the cloth in it. Using the gloves, place 2 or 3 pieces of dry ice into the water so you can create a lot of fog. Take the cloth soaked with liquid soap and carefully pull it evenly across the rim. The goal is to create a soap film that covers the top. Wow! What a great crystal ball! And pop it goes! Now you try. After you put the dry ice into the container, slowly slide the soapy cloth across the rim to make the crystal ball appear. Remember to be very careful when handling dry ice because it's very dangerous. And up it goes! Look at all that fog! It looks like a witch's brew. A scary smog of fog.
How does the smoke appear?
The smoke is actually a mixture of water vapor and carbon dioxide gas. It is created when dry ice comes into contact with the water.
What is dry ice?
Dry ice is a solid form of carbon dioxide. It is colorless, odorless, non-flammable, but it can burn your hand if you touch it, so be careful.
Where is dry ice used?
It is most commonly used to cool food products like ice cream and fresh fruit.
If it doesn't work at home, what should I look out for?
Remember that a bubble's worst enemies are dirt, oil, and rough edges. Make sure that none of these are present when doing the experiment. Now, we're off to go and visit a place that kids can only dream about. An ice cream factory. Come on! Chocolate or vanilla? Strawberry or caramel? Just about everybody loves cold, creamy ice cream. Today, we're making something creamy and mysterious. Wow! Look at that! That cream looks delicious. Can you guess what we're making? Any idea? It's a monkey ice cream cake. Yummy! When ice cream is in its final stage, it is preserved in dry ice and then transported in big insulated freezer trucks. It's getting cold in here. Let's get back to my lab, kids! Now for my green tip of the day. Don't let the tap run when brushing your teeth or washing dishes. Rather turn it off till you need it. Well, that was an ice day. Get it? An ice day? Today, we learned about dry ice. And we've also visited an ice cream factory. That looks delicious. That's all for today, kids. I'm off to eat my ice cream. See you next time. If you throw a ball up into the air, do you think it would float? Well, together with our studio members, we're going to learn about the remarkable art of floating ping pong balls. You will need some ping pong balls and a hairdryer. Now let's begin the experiment. Switch on the hairdryer, point it to the ceiling, and carefully put the ping pong ball in a stream of air. Hold the hairdryer very steady and watch as the ping pong ball floats in the stream of air. Wow! Look! It's floating! Now it's your turn. Carefully put the ping pong ball in the stream of air. Hold the hairdryer very very steady and watch as the ping pong ball floats in the stream of air. Carefully move the hairdryer and watch how the ball moves, staying in the stream of air. That's cool. Look at that! It's floating! Now kids, let's try something more exciting. Try putting another ping pong ball in the stream of air and see what happens. Wow! They're both floating! Amazing!
How do the ping pong balls stay floating in the air of the hairdryer?
The air from the hairdryer flows around the outside of the ball, and if you position the ball carefully, the air flows evenly around each side. Gravity pulls the ball downwards, while the pressure below pushes it upwards. This means that all the forces acting on the ball are balanced, and the ball sits in mid-air.
When we move the hairdryer, why do the balls also move?
The fast-moving air from the hairdryer creates a low air pressure, and the surrounding high air pressure forces the ping pong ball to stay inside the column, making it easier to move the hairdryer around without losing control of the ping pong ball. Hey guys, come and join me as I show you how amazing floating can be. Come on! Skydiving is great fun, and you can perform aerial acrobatics and various maneuvers all in mid-air before pulling the ripcord of a parachute. Many people make their first jump with an experienced and trained instructor. This type of skydive is called a tandem skydive. Did you know that the world record in formation skydiving was done with 400 men? Wow! Look at that! Skydiving with the car! That's amazing! It's skydiving! Okay, back to solid ground now, and I'll see you back at my lab, kids! Today's green tip is plant evergreen trees to protect your home from the chilling winter winds. Wow, that was great! Today, we learned how to make ping pong balls float and also learned more about skydiving. That was fun, but now it's done. See you later, kids! Today, we're going to demonstrate the incredible properties of air pressure with heavy newspaper. You will need some long wooden sticks, some large sheets of newspaper, gloves, and a table. Let's begin the experiment. Place a piece of wood on the table and let one end hang over the edge. Take the newspaper and fold it in half 3 or 4 times. Place the folded newspaper over the end of the wooden stick that is lying on the table. Put your glove on and make sure that everyone is standing away from the table as you hit the end of the stick that is hanging over the edge. Here! Watch as the stick goes flying. Now, take the same sheet of newspaper, open it up and cover the portion of the stick that is laying on the table. What do you think is going to happen this time? Do you think the newspaper is going to fly? Or maybe tear apart? Well, let's see. The stick breaks. Amazing! Now you try. Repeat the experiment and remember to make sure that you smooth the newspaper before you hit the stick. Kaleo chop! That's incredible! You're really strong!
How does that work?
It is the pressure of the air pushing downwards on the newspaper that prevents the paper from lifting.
Why must we smooth down the newspaper?
Smoothing down the newspaper is very important as it ensures that there's no air under the newspaper that might help it lift up when you strike the stick. So we've seen the kids doing the Kaleo chop in the experiment, but I think I'd like to see how the experts do it. Let's get into my space pod and go and see real martial arts in action. If you've ever wanted to learn how to break boards or bricks with your hands, then Taekwondo is the sport for you. Taekwondo means the way of the hand and foot. It is very physical, but besides getting an awesome healthy workout and learning self-defense, you can also learn important values like self-respect and respect for others. Kelly? Yeah. Let's meet back at my lab, kids! Let's go green with today's green tip. Turn off the TV when no one is watching it. The same goes for computers, radios, and other appliances, because it saves electricity. Today, we've learnt about air pressure. Hi-ya! And also about the martial art of Taekwondo. Now go out there and amaze your friends. I'm off to practice my new moves. Bye, kids! If you drop an egg in the water, do you think it would sink or float? Well, today, we're going to make it float like a boat. Float like a boat. You will need some water, 3 glasses, table salt in a teaspoon, and some raw eggs. Let's begin the experiment. Pour some water into the different glasses, not too full. Leave the first glass and add 2 teaspoons of salt to the second glass and 4 teaspoons to the last glass. Stir in the salt until it dissolves. Drop an egg into each of the solutions and see what happens. The egg in the first glass sinks to the bottom. Watch carefully now. Look at that! In the glasses where the salt was added, the eggs seem to float. The density of the eggs might vary, so experiment with different eggs. For the perfect salt solution, you may need to add more salt. Now let's see you try. Pour the water into the glasses. Remember not to make it too full. Add in the salt. And some more salt. Now stir. Put the eggs in and see if they float. In the glass with the clear water, the egg sinks. Now let's try the next solution. The objective here is to see if you can float the egg in the middle of the glass. If the egg begins to sink too much, you may need to add some salt to balance the solution. What happens now? It's floating in the middle. If at first you don't succeed, try again.
Why does the egg float?
The main reason why objects float is because of buoyancy. An object will float if it weighs the same as the amount of water it displaces. Salt water is denser than ordinary tap water. The denser the liquid, the more buoyant it is. This allows for an object to float in it.
Do the eggs have to be boiled or raw?
You can use a boiled egg, but for the best result, rather use a raw egg.
Can you use something other than salt?
Sugar will also work. Come with me as we go dive into the ocean in my submarine. A submarine has huge tanks called ballast tanks. The air in them allows the submarine to float. When a submarine has to dive, the ballast tanks are filled with seawater. This makes the submarine heavy and it sinks. When the submarine has to resurface, the water is pumped out of the ballast tanks and compressed air is forced in. Once the tanks are filled with air, the submarine becomes light again and begins to float. Let's go up, 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 like a periscope. Back to dry land, kids. Now for my green tip of the day. Buy fresh foods instead of frozen. Frozen food uses 10 times more energy to produce. Today, we learned about buoyancy and floating and went down under with a submarine. See you next time, kids, and remember to clean up after every experiment.